21. What is the approximate percentages of oxygen and carbon dioxide in inspired air? Inspired means breathe in. Yes, answer would be the percentage of oxygen. Oxygen is about 20% in the air. Okay, inspired air means haven't used up the oxygen, haven't done any gas exchange. It's just air on the outside that you breathe in. So 20% oxygen and very little carbon dioxide, 0.04. Yes, correct. Okay. Actually, if you can, if you know the percentage of carbon dioxide in our air is not very high. Not very high, right? Okay, so number 22, the flow diagram summarizes 3 different ways that glucose can be broken down to release energy. Alright, so here we have 3 different methods. Alright, which route involves the action of enzymes? Yes, the answer will be D, all 3, because enzymes, they are there to catalyze reactions. They carry out chemical reactions in the body, so they're like everywhere. Alright, so in this one we have 3 different reactions, so different enzymes. Okay, yeah, just simply because they're all like chemical reactions. So yeah, they'll involve your biological catalyst. 23. The graph shows lactic acid concentration in the blood during and after exercise. Right. So exercise, during exercise, recovery is after exercise. Ooh, okay. So you say answer is B. Which process accounts for the shape at graph at Z? You say B, which is aerobic respiration of lactic acid in the liver. Yes. Alright. First of all, during recovery, your body will switch back to aerobic respiration. Okay. First of all, difference between aerobic and anaerobic respiration. Aerobic respiration will have sufficient oxygen in the blood. Okay, so your body will carry out aerobic respiration. Anaerobic respiration is when there is incomplete breakdown of glucose in the body, okay, due to a lack of oxygen. That is anaerobic, right? And due to anaerobic exercise, this one will produce lactic acid. So you can see in the graph, when the blood lactic acid concentration increases, the part where it starts to spike, your body has already switched to anaerobic respiration. Okay, and when your body breaks down lactic acid is when the body has enough oxygen. So you have stopped exercising, you're panting a lot, right? So your body gets enough oxygen. So yeah, it starts to break down lactic acid, because lactic acid is from anaerobic respiration. It's produced from anaerobic, and when you have lactic acid buildup, it's not good because lactic acid is like toxic for your body. You don't want it, so your body will break it down when it has enough oxygen. Okay. Alright. As for number 24, the diagram shows shows the structure of the kidney. Okay, so where does filtration occur? Loop of Henle. Yes, D is the loop of Henle, but D is not the answer. That's not where filtration happens. Alright, filtration will happen here. Loop of Henle is this one. Where it happens at the glomerulus at 8. Okay, so but yeah, you're right. D is loop of Henle. Alright, so here in A, this is where your blood flows through. You see this little like net-like structure? Okay, the netting like that. that is where your blood passes through. So it's like all your capillaries all bunched up in there. Yeah. Okay, so all your blood vessels are bunched up there, and that's where the filtration, where all the toxins whatsoever will come out of your capillaries and enter the kidney for to pass on the, how to say, the waste, the toxin. Oh, okay, so where is the hormone glucagon released? Pancreas. That one is digestion. Yeah. Right. Next one, 25. The diagram shows section through part of the human eye. Yeah. So this one is the front part. Yeah. Right. What takes place when a person looks at an object which is far away from their eye? Okay. 20. Far away. Okay, suspensory ligaments and the lens. Okay, yes, I see someone with the correct answer. The answer for number 25 would be D. It is tighten the suspensory ligaments, which are these things. You see the little muscle-like structures? These two? These are the suspensory ligaments. The lens. Okay, when the suspensory ligaments tighten, they pull, sort of like you can imagine pulling the lens inner lah. Alright. Yeah. Okay, so it's pulling the lens inner. That's why it cannot become fatter, and the suspensory for C, suspensory ligaments cannot tighten and the lens becomes fatter at the same time, because the suspensory ligaments control the lens. Yeah. Okay, so they control the lens. So when they tighten, it becomes thinner. Right, this is for far away object, yeah.